An antiderivative of a function is just the opposite of the derivative. So if f of x is 3x squared and f prime of x is 6x, we say the expression 3x squared is the antiderivative of 6x. Because if you take the derivative of 3x squared, you get 6x. So the antiderivative of 6x is 3x squared. It's just backwards. So when we take an integral, we're taking the antiderivative of a function. And the area underneath the curve is represented by the antiderivative. So, back in 2.5, we learned about the power rule. The power rule, if you have a function x to the n power, the derivative is you bring the n down and you subtract the exponent by 1. So, antiderivative is the opposite order. So, step 1 is you're going to add 1 to the exponent. And then step 2 is divide by new exponent. So if you have a function f of x equals xn, to take the antiderivative or the integral, you add 1 to the exponent, so it's x to the n plus 1, and you divide that all by the new exponent, so divide by n plus 1. Some example problems. Given the function f of x, find the antiderivative uppercase f of x. So uppercase f of x, it's just this, we call this also the reverse power rule. So you add 1 to the exponent, so 2 plus 1 is 3, and you divide that by 3. You're also going to do a plus c, which is just represents a constant. The reason you do this is because if you take the derivative of this, the derivative of x cubed over 3 is the x squared, and then the derivative of a constant is just 0. Anytime you take an antiderivative, there should be a plus c, because if you take the derivative again, it just cancels out. So 2, first thing you want to do, you see we have a 6 over x cubed. Let's rewrite this. We are rewriting. We are not doing any antiderivatives yet. Rewrite the 5x cubed plus 6x to the negative 3 minus 1. Now that it's in the form that we want, we can find the antiderivative. So this is, leave the 5 in front. You add 1 to the exponent 3 here, so it's x to the 4th. Let's make them more clear. That's 5x to the 4, and then you divide, 5x to the 4, and then you divide that by a 4, plus 6x, negative 3 plus 1 is negative 2. Divide that by negative 2. And then the antiderivative of negative 1 is just negative x. You throw in a plus c. And then you can just leave it like that. Question 3. F of x equals root x plus 3 over root x. This is where you want to rewrite the function again. F of x is equal to x to the 1/2 power plus 3x to the negative 1/2 power. Now you can find the antiderivative. Capital F of x is equal to x to the 1/2 plus 1 is 3/2 over 3/2 plus negative 1/2 plus 1 is positive 1/2 over 1/2 and then plus c. You can leave it like this, but if you want to do the next step, x to 3/2 divided by 3/2 is just a 2/3 in front, plus 3 divided by 1/2, that's a 6, x to the 1/2 plus c. So the integral of sine of x is negative cosine x plus c. If you remember from earlier, the derivative of sine x is cosine x, but the integral of sine x is negative cosine x, because if we took the derivative of negative cosine x, that would be a negative sine x, and that would be a positive sine x. So the integral of cosine x is just the positive sine x plus c, because the derivative of sine x is cosine x. So another part of the fundamental theorem of calculus. So if you take the integral of f of x from a to b of a function f of x, that's just equal to the antiderivative uppercase f of b minus f of a. We're going to do some examples with this. So evaluate the definite integral, use a calculator to check your answer. So again, all these questions you can use on your calculator like we learned in the previous lesson, but we're going to try these by hand because you're going to need to know how to do that. So we have the integral from -2 to 5 of 4 minus 6x. What we want to do first is find the antiderivative of the inside part here. Antiderivative of 4 is 4x minus 6x squared over 2. And then you draw a vertical bar 5 to -2. So again, 4x, I'm going to rewrite this one time as 4x minus 6 divided by 2 is just 3x squared from -2 to 5. So what you do here now is you plug in the 5 into this function, and then you subtract, plugging in the -2 into the function. So it's 4 times 5 minus 3 times 5 squared. Plugging in the 5 first, then you subtract, plugging in the -2. So 4 times -2 minus 3 times -2 squared. Then plug in the -2. Eventually, if you do this all to the very end, you get an answer of -35. You do that on the calculator, continue by hand, you get -35. I'm just showing you the initial steps. The rest is just simple computations. Question 5. The next thing we want to do is this problem here. And the first thing we should do is rewrite it. X to the 1/2 minus x to the -2 dx. So now we can find the antiderivatives here. X to the 3/2, because it's 1/2 plus 1, divide that by 3/2, minus x to the -1 over -1, vertical bar from 1 to 4. And then just rewriting this. X to the 3/2 divided by 3/2, that's 2/3 x to the 3/2 minus a negative, oh, that's just the same as plus 1 over x. Because the reason being is because, well, minus the -1, that's just a plus, and then x to the -1 is 1 over x. Now we can just plug in the 4 into this right here, and then we can subtract, plugging in the 1. So what we have here is, do a square bracket, 2/3, 4 to the 3/2 plus 1/4. That's a 4, not a 9. Minus 2/3, 1 to the 3/2 plus 1 over 1. So if you do this all, continue from here, put in the calculator, you end up getting an answer of 47 over 12, or the decimal equivalent. Again, these answers, practice doing this on the calculator using the math 9, I believe, for the integral. Type this in to see if you get these same answers. Let's do this last one here. So you can bring the 4 to the outside. If you remember the definite integral properties. So from here we have a 4 times the integral of sine x is negative cosine x. Draw the vertical bar from 0 to pi over 2. Now We can do 4. Let's just make it like this. 4 on the outside, then we plug in a pi over 2 to the negative cosine x, so it's negative cosine pi over 2. And then we subtract parentheses negative cosine of 0. And then that ends up equaling 4. So this last question here, if f prime of x equals x squared minus 2 and f of 1 is equal to negative 2, then f of 3 is equal to what? So to do this problem, your starting point is f of 1, which is negative 2. This is negative 2 plus, and if you add the integral from 1 to 3 of the derivative f prime of x, which is x squared minus 2 dx. So what this is saying is negative 2 plus the change in the original function 1 to 3 will give you f of 3. Again, the integral of 1 to 3 of the derivative f prime of x gives you the change in the original function. So this right here would give you what f of 3 is equal to. And then if you continue from here, that's just equal to negative 2 plus x cubed over 3 minus 2x with the vertical bar from 1 to 3, which is equal to negative 2 plus 3 cubed over 3 minus 2 times 3. So we're plugging in the 3 into this function, then we're subtracting, plugging in the 1. So 1 cubed over 3 minus 2 times 1. And if you continue with this all the way through, you end up getting an 8 over 3. So again, for this type of problem, right, you have a starting point f of 1 is equal to negative 2. If you add the integral of the derivative from the start point to the end point, that gives you the change in the original function, which is this area right here from 1 to 3, and that gives you the new value, what f of 3 is equal to. You can go ahead and start the practice.